Hi and welcome. I hope everyone is okay. Now, in this lesson, we will solve some problem about the normal distribution, to approximation to the Poisson distribution, and we can start for the first example. Over the years, a biologist notes that a species of turtle lays on average 60 eggs in each nest. The number of eggs laid in each nest follows a Poisson distribution and is independent of the number of eggs laid other nests. Calculate the probability that in a randomly chosen nests that are exactly 50x over 74x and 40x or fewer. And we have some keywords in the question. The one of them, the question related to Poisson distribution, and we choose randomly. We choose nest randomly and independent. This situation shows us the problem is related to Poisson distribution, and for the A question, they ask us the probability of x exactly 50x. Exactly, you can use the Poisson distribution formula. If you remember that the Poisson distribution formula is the probability of r means lambda to r over r factorial multiply e to minus lambda, because we want to figure out the only one value probability. So we can use only the Poisson distribution formula. But in this section, we figure out by using the normal distribution. Exactly 50 values means in the on the graph, but beforely we should determine what is the lambda and the probability of r value. So the average 60x, they tell us the average 60x, it means lambda is 60, and lambda is 60 means in our graph, the middle of the graph, the point is 60. It means this part is 60. Okay, and we want to exactly 50 value. So 50 value means, for example, it's about it might be here 60, but this value exactly is 50 for Poisson distribution, but we want to figure out by using a normal distribution. So we should use the boundaries of rectangle, these bounds and these bounds. So this bound point is 49.5. This bound point is 50.5. If you use the normal distribution for exactly 50 values, you should find greater and equals than 49.5 and less and equals than 50.5 because the normal distribution is continuous distribution, and you should convert to discrete probability, convert to continuous probability. So in the normal distribution, for the normal distribution, you should figure out the x less and equals than 50.5, greater and equals than 49.5. The second step, you should make a continuity correction. So the probability of x 49.5 minus lambda 60 over the square of 60 and z 50.5 minus lambda over the square of 60. Okay, and I want to look at the these sections result for use short time, and this section, the result of this section is minus 1226 minus 1226. The result of this section is negative 1.256, negative 1.256, and we want to figure out the probability of z value. We want to figure out the probability of z value greater and equals than minus 1226, less and equals than minus 1, opposite, it should be opposite this. Yes. Okay. This point, yes, this point should be minus 1.356 minus 1.226. Okay, and I want to use the normal curve and the curve, the symmetrical curve, and the middle of the curve point 0 minus 1.356, and we have minus 1.226, and we want to figure out the between these points or these area. Okay, if you want to if you look at the z table and phi, excuse me, and phi 1.356, you can see the value of the big area, and if you look at the Z table, phi 1.226, you can see the big area, because phi minus 1.356 also the same, phi positive 1.356, and it shows us the value of big area, and the similarly calculation for 1.226. And I want to look at the result this section, because for in the last lesson we learned that how we find these values by looking at the Z table. So in this lesson I want to write a direct result for short time, and phi 1.356 means 0.9125, and phi 1.226 0.8899. Okay, the yellow area means 0.9125, the blue area 0.8899. If you want to figure out the between these points, you should subtraction for these points. So you should figure out the 0.9125 minus 0.8899, and it should be 6 and 4 and 2 and 0 and 0. So the interval area, the range of these points area is 0.0246. Okay. Now the other question. The other question is over 74x. Over 74x means x greater than 74, and it means the probability of x 75 plus the probability of x 76 plus infinity. So the probability, the sum of the all values probability is equals the 1. If you if you 1 minus the probability of x less and equals than 74, you can find the easily this section, because this process to figure out the this process very hard, and if you figure out the 1 minus the probability of x less and equals than 45, you can figure out easily this process. And but this probability this probability regards to uh, Poisson distribution, but we want to use normal distribution. And 74, lambda is the middle of the graph, lambda 60. For 74, like maybe this point, the middle of the rectangle, this rectangle, such as this rectangle, 74, and the middle of this rectangle about Poisson distribution, 74. But you want to figure out the less and accuse than 74. And the other way, you want to value, the probability is value includes 74. So you should take 74.5, because 74.5 less than 74.5 includes 74. When you use the normal distribution, you should use rectangle bounds. But in the Poisson distribution, all values show us the middle of the rectangle. But in the normal distribution, you should use the boundaries of rectangles. So if you want to values include 74, so you should use 74.5, because less than 74.5 includes 74. Okay, and we will use 1 minus the probability of x accused and less than 74.5. But we need to continuity correction. So 1 minus the probability of z less and accused than x 74.5 minus lambda over the square of lambda, and it means 1 minus the probability of z accused and greater than 1.872. And if you draw the curve, the normal distribution curve, the middle of the curve z point is here and 0, accused 0. 1.872 means less and accused than 1.872 means the big area. And if you look at the z table and you find the 1.82872, you could figure out the big area. Also you want to find the big area, and it means 0.9693. And we want to figure out the 1 minus 0.999693 and 1 minus 0.9693, and it means 0.0307 our result. Okay, now the other section, 40x or fewer. 40x or fewer. 40x or fewer means the probability of x less and equals than 40. Okay. Please remember that the average is 60. So the middle of this graph shows us 60. And 40 means like here. 40 means like here, the middle of this rectangle. But for the Poisson distribution, this point is 40. But if you want to use normal distribution, you should use the boundaries of this rectangle. 39.5 or 40.5. But if you want to find less and equals than 40, so if you want to include 40 value, you should use 45, less than 45, because less than 45 include 40. 45 boundary, the upper boundary of this rectangle, less than 45 include 40. So you should figure out the probability of x less and equals than 40.5, and it means we should make the continuity correction. Please don't forget, because we should use z table. The probability of z less and equals than z 40.5 minus lambda over the square of lambda. The result of this section, z less and equals than, means 2 minus 2.517 minus 2.517. Okay, and I want to draw the curve regards to z value is 0 minus 2.517 means this point, and we around the z less and equals than minus this section. If you look at the z table and phi 2.517, also the same negative 2.517, you can find the big area value. the big area value. In the when you look at the Z table and you find the 2.517, the big area value is 0.9941. But you want to find the small area, and please remember that the sum of the all values probability is 1, and if you want to figure out the small area, it's also Z less and equals than minus 2.517. You should find 1 minus 0.9941, and it means 9, 5, 0, 0 and 0. Our result is 0.0059. Okay, the other problem, it's thought that the number of pulseless on a given stretch of road occurs at the rate of 2 per week. Assuming that pulseless occur independently at random for pulseless occurring on a stretch of road, calculate the probability of. Okay, now in this question we see independently word and at random, and we have a average 2 per week. So it means that the question regards to Poisson distribution, So because please notice that independently sentences and random, and the rate of 2 occurs at the rate of 2 per week. So our lambda equals to 2, and the question is regards to Poisson distribution. Exactly 2.5 potless. Exactly 2.5 potless to the probability of x exactly 2.5. Certainly you can use the Poisson formula because you want the probability of only one value. But I will use the normal distribution, but I will need to make something. The first step, Poisson distribution is discrete distribution, and the middle of the curve means average or lambda. Lambda is 2, and exactly we will around exactly 2.5. 2.5 means this. For the Poisson distribution, this section, this value for the Poisson distribution, if we want to pass the normal distribution, we should make continuous data. So the probability of x greater and equals than 2 and less and equals than 3. Okay, and the second step, we should convert to z value, and x minus lambda over the square root of lambda z x minus lambda over the square root of lambda. It means the probability of 0, and I want to compute by using calculator 1 over the square root of 2. 1 over the square root of 2. 1 over the square root of 2. It means 0.070, and I want to draw the normal distribution curve regards to z value. 0 is here, 0.7 here, and we want to figure out the less and accused than 0.7, so it shows us the big area. And if you find the in the z table 0.07, excuse me, 0.7, you will already find the big area. Okay, 0.7 means 0.7 0.758, 0.758. Okay, the other question, over 10 potless in 1 month. Please notice that they give us per week, for per week lambda 2, but they ask us for 4 weeks. So we should find the new lambda for a month. Our lambda equals to 2, but for 1 week. If we want to lambda value for 4 weeks, we should multiply 4 by 2 equals to 8. The new lambda is 8. Okay, and over 10 potless. Over 10 potless means the probability of x over 10. And if you want to exactly over 10, you should make the normal for the normal distribution, make the x value x greater and greater and equals than 10.5, because you don't want to include 10. Exactly greater than, exactly over 10, they tell us exactly over 10. So we will convert to z value the probability of z greater and equals than x 10.5 minus lambda over the square of the lambda, and it means the probability of z greater and equals than 2.5 over the square root of 8. Okay, I want to use calculator. 2.5 over the square root of 8, the square root of the 8, the square root of the 8 means 0.88, approximately 0.88. The probability of z greater and equals than 0.88. Okay, I want to draw a curve regards to z value is here it's 0 point, and I want to figure out 0.88 and greater and equals than 0.88, and I want to figure out this area. This area is a small area, but I knew the all probability, sum of all probability equals to 1, and if I look at the z table 0.88 value, I will find the big area. So it means 0.88, 0.8 and 0.8, this value 0.8106, 0.8106, 0.8106. But this value for big area 0.8106, but we want to find the small area because greater and equals than 0.88 means small area. So we should find 1 minus 0.8106, and it should be 49810, 0.1894. The other problem, 50 platelets or fewer in 6 months. 50 platelets or fewer. Okay, in 6 months means please remember that in 1 month, lambda equals to lambda was 8. So lambda equals to 8, but 1 month. But we should find for 6 months. We should multiply 8 multiply 6, 48, and we want to find the probability of 50 platelets or fewer. 50 platelets or fewer. X less and equals than 50. So we want to include 50 for the normal distribution. We should find x less and equals than 50.5, because less and equals than 50.5 includes 50. And the second step, we should convert to z value. So the probability of z less and equals than x minus lambda, but we should use new lambda, 48 for 6 months, 48 over the square root of 48. So the probability of z 2.5 2.5 over the square root of 48 means 0.36 0.36, and I want to draw the curve regards to z value is 0.36 here, and we want to z less and equals than 0.36, so we want to compute the big area. And if you look at the z table, you can already find the big area, 0.36. Okay, 0.3 0.36, 0.3 and 6, 0.6406, 6406, 0.6406. Okay, and then the last question, equivalent greater than 105 less than 110, equivalent greater than 100, equivalent greater than 105 and less than 110. But these interval according to regards to Poisson distribution. But while passing the normal distribution, you should use the boundaries of rectangle. So you want to include 105, so you should use greater and equals than 104.5, because 104.5 includes 105, and the upper bound for the upper boundary 110, you don't want to include 110, so you should use 109.5. So the second step, you should x value convert to z value. So the probability of x, but don't forget lambda, the new lambda, we will compute for 1 year, for 12 months. For 1 month, our lambda was 8. For 12 months, lambda 8 for 1 month, but for 12 months also certainly 1 year, it should be 96, and we will x values convert to z values, and x 104.5 minus lambda over the square root of 96 and less than or accuse x 109.5 minus lambda over the square root of the 96, and for the first process, this process should be excuse me, that the probability O should be okay, 8.5 over the square root of 96. The square root of 96 becomes 0.86. 0.86. Okay, and the other process 13.5 minus 96, excuse me, 13.5 over the square root of 96. The square root of 96 becomes 1.32. 1.32. Okay, I want to draw a curve regards to z value is here 0, 0.86 and 1.32. We want to figure out between these points. Okay, and please remember that if you want to if you look at the z table for the any value, for example this value, for example 0.86, you can find the big area. You can find the big area, and the left of the 0.86 point big area, and when you look at the z table, you can find, you will find this area. And when you look at the z table for 1.32, you will find this area, and blue area minus yellow area, you will find green area. You will find green area. Okay, now I want to find 1.32 before the, then 0.86 by using z table. 1.32, 1.3 here, 1.32, 0.9066, 0.9066, 0.9066, and 0.86, 0.86 means 0.8 here, and 0.81, 2, 3, 4, 5, 6, 0.8051, 0.8051, 0.8051, 0.8051. Okay, And if you remember, the blue area, this area, the big area here, the big area, the yellow area here, and if we blue area minus we figure out the blue area minus yellow area, we can we will find green area also. Certainly we around this area. 0.9 T66 minus 0.80 51. 8051. I want to look at again. 0.86. Yes, 80 51. Okay, and it's 5 1 0 1. So our result is 0.1015. And so we could finish the Poisson distribution. As for now, our lesson is finished. I hope the lesson was useful for you. Have a good lesson. Have a good day.